Well, good morning, everybody. Welcome to the webinar. We've got about 4 or 5 more minutes here, so you've got last chance to get a cup of coffee, use the restroom, something like that. And looking forward to joining you, and hopefully you'll enjoy this. So I've got Arneh on the line. Arneh, how is Southern California? Is it nice and warm out there?
It's actually not. We had a lot of rain actually over the past couple of weeks, and it looks like there's more rain to come over next 2 days, which is not normal for LA
LA?
for sure.
Yeah.
Yeah, exactly.
Yeah, we actually had rain the
Yeah,
other night, and I was downtown all weekend, and it was warm here in Denver. It was actually
oh, nice.
50s or so, and so I was out in shorts and doing some stuff, and then Sunday night it started to snow, and by the time I got up yesterday, everything was white.
Yeah.
We got 3 or 4 inches. So
Wow. Wow, that's awesome.
Yeah, so it's kind of crazy, especially after I was in the UK last month, like 3 weeks ago, and it snowed every day I was there, if you can believe it.
I know, right? You actually
So
get some snow over with you.
yeah. Now I was hoping I'd get more snow, but live with what we got, right? That's what we have to do. So
Exactly.
hopefully we'll get a little bit more, and it's not such a dry spring because, like California, we worry about fires here. So
Of course.
it's a tough area. But
Exactly.
all right, so we still got a couple more minutes before we go. While we're waiting, I know this is a Redgate webinar. We talk about it. Arneh, have you been playing with the data masker and SQL provision very much lately?
I have, yeah, especially with Data Masker. It's a new product for us, so I've been talking to more customers about it recently, and now that we can actually mask your data as part of SQL clone and be able to just provision database down to lower environments and have a masking project that masks your data as it's doing that,
Yeah.
it kind of builds a nice story. So yeah, it's been coming up a lot more in conversations now.
Yeah, when I first got it and I started to use it, it was a bit confusing, right? Like it's not like a normal Redgate product.
I agree.
But
Yeah.
as I use it more, I'm like, it's actually kind of a cool little tool, and it's very helpful. So
Yeah, exactly.
I'm
Especially
looking
now
forward.
with V2, we've been updated the UI and built the integration into Clone. It's a lot nicer now.
Yeah, it is kind of cool. And for those of you who haven't tried it, maybe give it a try and look for the pink elephant that's in there, and or pink rhino. I think is a pink rhino. Is that what it is? Yeah.
It is. Yeah.
There's actually a switch to turn that on and off. And what's funny is some people really like it on, some people really like it off, and it's kind of amusing to run into those people. So
yeah, totally agree.
all right, let's see. Got another minute or so, and we'll get started and see people joining in. So welcome everybody. Hopefully you've got some great questions. We have some interesting stuff to show you today. So let's see. Let me make sure. Okay. All right, I've got the recording. Arneh, is your demo ready to go? You set up?
Yep, all set.
All right, so let's get started. Well, welcome everybody to our Extending DevOps Practices to SQL Server Databases webinar from Redgate Software. I'm Steve Jones, and I am going to kind of MC and host this today. For those of you that don't know me, I've been a DBA and developer and manager of database and software systems for a long time, and actually been working with SQL Server for 26 years now. So it's been a long career for me. I also run SQL Server Central, which is a website where we try to educate you. And so my job is really to help you get better at your job. And that's what I've been doing for quite a while now. I do work for Redgate as an evangelist, so I'm hosting the webinar today. And I've got all my contact information there. If you have questions or you're confused by something, please feel free to get a hold of me. And then my partner today is Arneh Eskandari, who is a sales engineer with Redgate. And Arneh, let you introduce yourself.
Sounds good. Good morning, everyone. My name is Arneh Eskandari. I'm, as Steve mentioned, I'm on the sales engineering side here, working very closely with our accounts team and also our Redgate customers. our main area of focus recently has been DevOps, as some of you might know. So we've been working with a lot of customers, helping them implement DevOps on their databases, as well as implementing best practices around delivery of database changes. So I'm excited to be running the demo for you guys today, and here is my contact details. So if there's any questions after the webinar, feel free to reach out.
All right, thank you, Arneh. So a quick agenda today. I'm going to talk through a few things, and then really we want to try to spend most of the time on the webinar. So I'll turn it over to Arneh to show some of the details there, because he does a fantastic job. And for those of you in the US, you probably would work with Arneh if you're trying to do proof of concept or something else. A couple of just quick housekeeping items. We are recording this webinar, so if you do need to drop out or you miss something, it will be available probably in a couple days for you to rewatch. It will be posted on our YouTube channel. There's a Redgate Videos YouTube channel, and everybody should get an email that lets them know where that is. And then also, you have a GoToWebinar control panel. It's usually in the upper right-hand corner, kind of minimized. But if you go to that, you can open it up and ask questions. And so if you have questions while we're going along, please feel free to ask them, and either I'll try to type something into the box or I'll ask Arneh and we'll try to build it into the webinar itself. And then we have a few polls as well. We would really appreciate if you would just take a moment and answer those as they pop up, because they're helpful to us to just understand your needs, our audience, and how we can do a better job. So with that in mind, let me take a minute. Let me talk about Redgate here. So Redgate's a company that's been around for a long time, and it's been a company that builds software tools to help software developers build their own software, right? Whether that's .NET software, which we have some tools for that, or database software, which is where we really focus. And our philosophy is really to do these ingeniously simple tools that solve problems and make you much more efficient DBA or developer. We sell to all the huge companies out there, all the Fortune 100 companies, hundreds of thousands of customers across the years, and we try hard to build solutions that are useful to you. And we also believe in giving back, and so Redgate does support the community and try to not just ask you to buy software, but we want to help you as well. And so Redgate started simpletalk.com, which is an educational journal, and then they bought SQL Server Central, which I started a few years ago as well. And our goal is really to provide you information that makes you a better DBA, developer, manager, whatever. So, nope, over there, let me go here. So DevOps, as Arneh mentioned, is what we want to talk about today. And plenty of people have been moving into DevOps. For those of you that might be developers, you've probably thought about it, heard about it, read about it, or maybe trying to do it. We find that database people sometimes are a little bit behind. And there's this challenge with building database software into the DevOps process. Really it's around the data. Our data in the databases, businesses rely on it. It's very important. And so as we want to make changes, as we try to evolve software and applications, we have to make sure that our data is, correctly preserved, and we protect it and make sure that it's safe. And the challenge with that is, as we want to roll out and update our software, whether that's the front-end application software or that's the database itself, we have to make sure that the state of the data is maintained and it's properly managed. Sometimes we have to alter data or change it as part of an update to software or part of a patch, but we have to be sure that we don't adversely affect the data. And so that's a challenge in database. And when we don't do that well, what we find are a lot of these challenges. Now, many of you that may be working in DevOps probably find that the database is a little bit of a bottleneck, and it's moves at a different rate than your .NET or your Python or your Java or your other application software. And that's because we have to preserve state. The other thing, though, that happens if we don't have a smooth DevOps type process is that we often don't know exactly what changes are made and when. We don't have an ability to roll back because we don't know what the previous version is. And we can talk about rollbacks a little bit, but rollbacks are always a challenge. However, if you don't even know what the previous version is, and that's a huge problem. So many of us kind of view the code in the database as its own, state, its own capture of where it is. But as we change that, we don't have a way to get back to the previous version if we haven't captured that. The other thing is that many of us probably have found that releases are risky. They're problematic. They may cause us a lot of stress. And so as a result, we try to avoid them and we release less often. And it's not just individuals, but the business, the organization often feels this way. When a release causes problems, we get scared and we try to limit the number of releases in the future because we want less problems. And then, of course, they take a lot of time. We have manual processes that just eat up hours and prevent us from doing other work. And really, they're tedious, mundane type things that smart DBAs and developers shouldn't be doing. So we want to be sure that we try to avoid those. So as we move to a database DevOps process, what we really want to do is have repeatable, reliable releases. I know it's a lot of R's, but ideally what we want to do is understand exactly what's going to happen in the release. All the steps are followed. We don't forget to assign security or test something or anything else. And we do this really through automation by trying to avoid counting on Brent or Steve or somebody else to make sure they do this one thing that they always do when we release software. All of us have probably known somebody or been that person that everybody counts on to remember all the steps and to do things in order and to be able to fix something. We want to eliminate that in database DevOps. We want to make it kind of a predictable process that goes. And then in DevOps, often what we're trying to do is make small units of change. So we want to make small feature change, test it with our users, see if they like it. And then if so, we add to it. If not, we undo it, do something else. We want to do that with database as well. So by moving to a more predictable, reliable release process where we can release more often, we can make these smaller units of change. That's certainly a cultural challenge to change that mindset in your DBAs and developers, but tooling makes that easier and helps it. And of course, we want to make sure we test our software. I hate that this is last. It's always last on the slide. And I don't want it to feel like it's an afterthought because I really believe that the more we test our software, the more that we evolve our automated tests, the better our quality is over time. And plenty of organizations have proven this, but it still seems like the minority of us actually do this testing. So, at Redgate, we try to preach testing. We have some tools that are designed to help you test, and hopefully as more of you actually start to test, we'll build more tools as well. And every year, Puppet Labs does a state of DevOps report, and at Redgate we've started to do a state of DevOps, database DevOps report as well. And this past year, the one that we just released talks about a number of things that we got from a survey. And one of those is that we see this trend where more and more companies are moving to a DevOps environment. We see that from our customers as well as potential customers. And so if you're not thinking about DevOps or moving there, you're going to be a little bit left behind. And so we want you to kind of think about an idea. And one of the drivers for including a database is that we want to be sure that the database keeps up with the application software. And so because many teams have people that are responsible for both or they're involved in both, they don't want to be the one person or the part of the team that's the bottleneck. And so they are trying to drive the database to be a part of the DevOps process. We have the full report. You can read it, and it's got lots of wonderful images that help state things out. But the idea is that more and more people are moving in this direction. And then last year, our 2017 report was similar to what Puppet Labs finds with their just overall software report, in that just making some small changes in your system, like using version control, automating your releases, that strongly starts to indicate that your IT performance rises. It becomes better than average. And for most of us, that means that we can become better than our competition. The organizations that do start to adopt these things and that become high performing, which means that they're meeting the goals of their organization at a faster rate, they're deploying code more often with less failure. And that's the key, right? It's not that DevOps isn't about just going faster and deploying more code. I have to be better at deploying code so that I have less failures in my deployments. And if I do have an issue, I can recover much, much faster. And those are key items, especially for those of us that work with data. And then, of course, the ultimate driver is that these high-performing IT organizations tend to just do better for their business, right? They make more money, more revenue, more profit, more market share, whatever it is, because they can respond quickly and rapidly to the business without doing this big project that takes months and months and months. They tend to just perform better. So at Redgate, we're trying to help you with the database side of things. And so I'm going to let Arneh kind of walk through a little bit of what we can do and what we're going to show today, and then he'll actually show you the demo. So Arneh, why don't you take it away?
Sounds good. Thanks, Steve. So, so this diagram nicely summarizes a typical development and the change management process on the database side of things, and generally on any application code. and also how Redgate tools fit into this process. So here we're looking at a typical development and an operations pipeline when it comes to promoting changes against your databases. And in the middle section, we have the Redgate tools that can help you with any one of these areas. Obviously, there is different components, combinations of good practices that are required for a good DevOps process, and that always starts with source control on the left side of things. So as part of our session today, you'll see how Redgate can help with source controlling of database changes to start with. Once you have source control as your single source of truth and whatever that you want to promote to your higher environments is in source control, then you can start looking at setting up an automated build and automated validation process when you're automatically testing your changes and making sure that everything looks valid before you start promoting those to higher environments. Obviously, today's webinar has a big emphasis on automated testing, which is something that we're not used to on the database side of things, right? If you look at any application code, developers are used to, running unit tests, running static code analysis tests, and things like that. But it's not a common practice on the database side of things. So as part of today's session, we'll also look at how Redgate can help build automated testing into the process. And as part of that build process, we package up your database for deployment. So Steve, if you could click on that. Yep, so we talked about the continuous integration side, and if you could click once more, and once we package up the artifacts as part of the build, then we prepare this for releases, and you can just use any release management tool, whether you're using TFS end-to-end or Octopus Deploy or any other release management tool, then you can easily plug our components into that. So DLM automation is what we'll be covering on the build and release management side of things, and we'll be looking at SQL source control, SQL test, and SQL prompt on the development and the testing side. At the bottom, you can see we plug into pretty much any source control system, any builds or release management tool. But our today's focus is primarily on VSTS. So we'll be using VSTS or TFS as our source control, as well as VSTS for our build and release management. All right, so now let's go ahead and take a look at the tools. So before we do that, while I'm sharing my screen here, I'd like to run a quick poll here just to see how familiar everyone is with Redgate products.
All right, so got some people voting. If you could take a minute and answer. I was going to try to answer Arneh, but apparently organizers can't answer.
I think that's intentional.
Yeah. Don't want to mess up the data, right? All right.
Exactly.
Cool. Well, thanks everybody. I think we got about 70% voting.
Yep.
So let's jump over, and of course, compare is always at the top of the list because most people use that, and I'm sure prompt is the large part at the bottom.
Exactly, yeah. And I'm glad that a good number of people are already familiar with SQL source control, which is one of the components that we'll be talking about today as well. All right, so let's go ahead and close this and start sharing my screen here. Okay, Steve, would you be able to confirm that you can see my screen okay?
Yep, I see Management Studio just fine.
Okay, perfect. So here I have a couple of databases that we'll be working with today. So I have this particles database, which I have a couple of copies of that for different environments. So for the purpose of demo, everything is set up locally on my machine here, and therefore I have these databases that represent the different environments on the same SQL Server instance. So the first thing first, making sure that the database that we're working with on the development side of things is indeed linked to source control, and we can easily source control our changes. So with the help of our SQL source control tool, I can easily keep track of the changes that I'm making to this development database, and also making sure that I'm committing all of my changes to source control. And that's the reason why the database icon here is green. This is an indicator of the database being linked to source control through our SQL source control plugin. So what we're seeing here in the middle is our SQL source control, which acts as a bridge between your development database and your existing source control system. So if I take a look at the setup for this specific project, as you can see, my database is linked to VSTS, and it's currently linked to this specific project and this specific database folder within the Particles project. All right, so before I go ahead and start making changes, I quickly want to make sure that there's no pending changes for me to commit into TFS. Okay, so as you can see, currently there's no pending changes. Before I start making changes, there's a couple of things that I'd like to walk everyone through. One is what source control actually looks like in using SQL source control. So if you go ahead and take a look at our code here, here is the database folder that we've linked our database to. And this is the folder structure that SQL source control creates. As you can see, there is a subfolder for each class of object, and we store the definition of the objects or the create scripts of the objects within these folders. So we can't follow a state-based approach. As some of you might know, we actually have two approaches to database change management. One is more of a migrations-based approach through Redgate. We've done some webinars on Redgate and as well as DLM Automation. And we also have the state-based approach through SQL Source Control and DLM Automation. So our area of focus today is on just state-based approach and using SQL Source Control and DLM Automation to promote changes to up the chain to our higher environments. So I'm going to go ahead and start making some changes here. Let me just turn off my notifications. I should have done this earlier. All right. So let's go ahead and start making some changes. So as I mentioned, our main area of focus today is going to be testing. So we have a couple of tools that can actually help you with introducing automated testing or unit tests, as well as code analysis testing into your database project. One of those tools is called SQL Test. So SQL Test is another plugin to SSMS, which actually has two testing frameworks built into it. One is the T-SQL-T framework, which is an open source unit testing framework. And the other one is SQL Cop, which is a static code analysis testing framework where you can test for best practices or issues found within your database. So SQL Cop provides you with a set of tests out of box. So for example, you can see, testing store procedures, naming conventions, and different types of things, performance tests that you can just get out of box by installing SQL Test against your databases. And then on the other hand, we have the unit testing through T-SQL-T, which actually requires you to write unit tests to make sure the business logic or the functionality of your store procedures, your views, your functions, etc. Another great thing about this, so with any unit testing tool out there, you also want to be able to see how much of your code is actually covered by unit tests, right? So the code coverage plays a really big role in terms of enforcing developers to unit tests, to write unit tests for their changes, and also making sure that majority of your code is covered by unit tests. So that's the code coverage built into SQL Test that can help you with that. So if you take a look at my current database here, and let's just run all of our tests, make sure that we don't have any failing tests against the database as of now. Okay, so we can see all of our tests passed, and you can see the code coverage details here on the right side. So we can see exactly what store procedures, what functions are covered by unit tests, and we can see how much each of these objects are covered by. So this is a great tool to kind of help you keep track of any new objects that you've added or program objects that you've added where you haven't, where you don't have a unit test for. You can also use this tool to, as part of your automated build process, to either give you warnings or fail your build if your code coverage goes below a certain threshold. So later on, as part of our build process, that you see that we've set a threshold of 50% for our code coverage. So if we just keep adding objects and without adding any unit tests, at some point that threshold is going to go below 50% and it's going to start failing our build. So it's the great thing about this is that you can actually be consistent with this process by automating a lot of these tests, as well as the code coverage and checking to make sure that majority of your code is covered through automated testing. So so without further ado, I'm going to go ahead and start making some changes here to our database. So let's take a look here. So I'm going to make some changes here. So let's start up by making a table change here to this particle table. Just going to add a column called reference. Okay. And I'm also going to add a new store procedure. So using SQL prompt, some of you, it looks like, are already familiar with SQL prompt. So which makes writing SQL a lot easier and smoother. So here I'm just using the snippet manager of SQL prompt, where you can add your own snippets or use some of the built-in snippets of SQL prompt to just be able to write SQL a lot faster. So I'm just typing CP, and that gives me the template for creating store procedure. So I can go ahead and easily create a new one without typing everything from scratch. So let's just return some data here. Another great thing about SQL prompt is that we've actually built the static code analysis similar to the ones that you just saw as part of SQL Comp into SQL prompt. So as you're typing in real time, SQL prompt would let you know if there is any bad practices or any issues found within the SQL script or the object that you're working with. So for instance, here you can see anything that has a green squiggly is basically SQL prompt complaining about something. So if I hover over the star here, as you can see, it says that you're using an asterisk in a select list, which is bad practice. So you have to be more specific and specify columns. And if I hover over everything else, you can see what it's complaining about here. So I have a parameter here that I've declared, but I've never used it. So I can actually get rid of that in this case. So these are the rules that are defined within SQL prompt code analysis. So you can easily go ahead and customize them. You can specify which one of these rules you care about, which ones you don't care about, and kind of customize that for your development or for your team. Another great thing about this is that the static code analysis also comes with a command line that you can run as part of your build process. So if, for instance, your developers forget or they miss a specific thing, then you can make sure that these rules are ran automatically as part of your build process and can capture any issues found within your code. So just to demonstrate that as part of the build process, I'm actually not going to remove this asterisk here, and I'm just going to go with it. Let's say that I just missed that as a developer. So we made a couple of changes here to our database. I'd like to go ahead and commit my changes to source control. As you can see here, it shows us what objects have changed and by which developer. So typically there is a couple of approaches that database development shops take to database development. One is everyone just works with a shared database, which is obviously it's a bad practice because people can easily step on each other's toes before they get the chance to commit their changes to source control, and it's just a single point of failure. So instead, you can have each developer working with their local schema. And using this tool, it actually makes it really easy because you can easily link any database to a given source control repository and use the Get Latest tab here to see if there's anything within the repository that you don't have on your local database as a developer, and be able to bring those changes and apply them to your development database. But in case if you're using a shared database, then we provide you with this last change by column here, which shows you which developer has made which change. So that way you can make sure that you're only committing your changes that you've made against that development database and committing them to source control. So here at the bottom, for those of you who are familiar with SQL Source Control or Compare, we kind of show you a side-by-side comparison of what the object looks like in your development environment and what it looks like in your source control repository. So in this case, we've added a new column, so it's reflecting that here at the bottom. And we also added a new object that doesn't exist in source control yet. So we're going to add that to source control. So I'm going to go ahead and write my comment here. So added a new column to article table and added a new store procedure to return article data.
That's all right. Spelling doesn't matter.
Exactly, yeah. Especially if you're in a demo.
Yeah. So, hey, while that's committing, Arneh, let me launch this poll. I'm just curious what source controls you guys use out there, because you know, we believe source control is really valuable. You know, the more that I use it and the more that I found it, it just builds better habits with you as a developer, and you know, it provides you a little bit of safety net. So you know, you should definitely use source control. You know, whether or not you want to use our products or not, you should use source control. We'd love to have you use SQL Source Control for Management Studio, but just please use it. So, all right, let me close that poll, and then let's get on with the demo.
All right, perfect. So it looks like there's a lot of Git and TFS users. So it's interesting because, you know, looking back a couple of years ago, Git wasn't really that popular as a source control system because it was a bit of a learning curve, even though it's in my opinion, it's the best source control sort of system out there. So it's kind of nice to see that people are actually utilizing Git more, and either through TFS or any other Git server or Git repository. Okay, so basically what happened, so I committed my changes into source control, and that went ahead and triggered a build in my CI environment. So here I have this build definition in TFS that is utilizing the extensions that we offer on the DLM automation side, as well as the command line of the static code analysis that I mentioned, as well as the code coverage. So if you take a look at our build definition here real quick, just to see what we're doing before we take a look at the build log. So we offer extensions for Redgate DLM Automation, as you can see, for TFS. So you can easily go ahead and download and install these extensions from the Team Services Marketplace or the Visual Studio Marketplace. And we are also utilizing the command line of the code coverage tool through a PowerShell script, as well as the SQL code analysis, which is the SQL code guard, which is built into SQL prompt to basically catch those bad practices or the failed test as part of this process. And we're finally just publishing the artifacts or the results of our tests as an artifact to our build process, so we can easily see those. What we're doing as part of the build process to begin with is that we're basically trying to build the database from scratch, mainly just the schema and whatever lookup data that you've linked to source control through our SQL source control tool. So the idea here is to make sure that we can build your database from scratch. When you're building an application, you know, the idea is that when you compile your whole solution, and that should be able to compile. You can rebuild basically your solution successfully. So it's the same idea here with databases. So we're just rebuilding the database from scratch on a temporary database. In this case, I'm pointing it to this particles build database that I created specifically for the build. If you can build database objects from scratch, then we move on to the next steps, which is running the unit test. Once we run the unit test, then we run the code coverage to make sure that most of our code is covered, or it hasn't gone below that threshold that we've set. And also the static code analysis, which runs on top of the unit test. So there's two types of tests, as I mentioned, that we can help with. So unit tests as well as static code analysis. And you can run all of those in an automated fashion as part of your build process. So that's what we're doing here, and finally publishing the results to our build. So let's go back to our build and take a look at the summary and see what happened here. Okay, so you can see that it partially succeeded. So we can see that if you take a look at the code coverage here, you can see that the expected code coverage is 50%, and we're actually at 80% as of now. So things are looking good on the code coverage side of things. We can take a look at, you can see our unit tests, they all passed. So we can go back into our build and take a look at the tests that we actually ran as part of those unit tests. So we can clear this. We can see all of those tests that we added to our database through T-SQL-T and SQL Comp, and we can see which one of these tests, in this case, they all passed, but if any of those failed, then you would see those here. You can also see how long it takes to run any given test that you have within your project. Moving on, if you take a look at the static code analysis here. So let's take a look at the logs. As you can see, it says some code analysis tests failed. Check the test report for details. So let's go back. Let's go and take a look at our test report and see why code analysis failed in this case. So I'm going to take a look at our SQL Code Guard test results here, which is an XML file. So as you can see, it caught that issue with the store procedure that we created. So we have an asterisk in the select statement, which is a bad practice, and we want to fail our builds every time we have a select star in any object. So I've got to go back and quickly fix this and rerun the build so we can then have a successful build and be able to promote that to our higher environments. So let's go back and quickly fix that. Okay, so let's just use the wildcard feature of SQL prompt here and commit that back into source control. Okay, let's go ahead and commit that. This is now going to trigger another build. Another thing that I'd like to point out here is it's really easy to actually get up and running with our SQL test. So once you have SQL test installed, you can actually, there's a sample database that you can use. So here you can see there is an option to create a sample database. I'm actually using the sample database for this demo, which provides you with a sample database which already has some unit tests in there, so you can take a look at the unit tests and kind of see what they look like. And you can also take a look at the code coverage. So once you install SQL tests, you can just create a sample database, and that will get you up and running with some unit tests and the code coverage that you can start testing with or playing around with. Okay, now let's go back to our build process here. Okay. So the artifact of our build is for the release side of things is a NuGet package. So if our build succeeds and we validate everything and the database looks valid, then we go ahead and package up all those files that we looked at in source control, so all those create scripts or the state of our database, into a NuGet package which acts as a lockdown version of your database that now you can promote to higher environments. So the idea is that we build it once and then we'll deploy that package to multiple environments. That's assuming if everything, all the tests pass in the higher environments, and we just keep promoting that package all the way to production. So in this case, let's take a quick look, make sure everything looks good. So, okay, so you can see now all the tests pass with our static code analysis. It still returns an exit code of 1 that I kind of forgot to handle in my PowerShell statement, so it still kind of gives us a warning, but that's okay. We don't have any failures in this case, and we can see that we were able to publish everything successfully. So I'm going to take a look at our artifacts real quick again. So we've got our code coverage report, so I'm going to take a look at that. As you can see here, it shows us what objects are covered through unit tests. So we have a couple of objects that are covered 100%, but also a couple of objects that aren't covered by unit tests, including the store procedure that I created, which is not currently covered. And that obviously brought the threshold, our total coverage down to 80% from 88% that we had. So this tells you exactly which lines within your object are covered. So anything green is covered through a unit test, and everything else is not covered. So it's a nice report, and which makes it really easy for you to see exactly where you have code coverage and which areas you need to add tests for. Okay, and as part of the artifacts, as I mentioned, we have the NuGet package that we built. So a NuGet package is built from a given build, and we version the NuGet packages based on the build number from TFS. So that way you can, if looking at any given build, you can see exactly, or looking at any given package, you can see which build it actually came from. So now our next step is to take this package that we built and promote it up the chain to our higher environments. And we're going to do that through the release management component of TFS. Before we do that, Steve, should we run another poll here?
Sure.
To see what build and
release
our audience are. Yeah.
So let's ask you the CI systems, if any of you are using CI, whether this is for their database or application or anything. We're just curious what's out there. They all work roughly the same, Bamboo, TFS, TeamCity, Jenkins, Hudson, Cruise Control. They're all, they're step engines, right? They just kind of work. The other thing, Arneh, I want to mention too is that some people may not know what a NuGet package is if they're not a software developer, and it's kind of just a zip file, right, with some metadata stuff around it.
Really
all right.
Good point.
Yeah. So let me close this poll. Let me pop over and let's just run the release management one real quick. So release management system is kind of like a build engine. It just is designed to run a series of steps that understand how to release software, right? And they're all roughly the same. I mean, Arneh, you worked with most of these. They all work pretty much the same, right? For you,
pretty much, yeah. Yeah, I wasn't a big fan of TFS until a year or two ago because it was kind of clunky, and they had this standalone release management tool, as you know, which was really difficult to work with. But now, obviously, TFS has come a really long way, and it's just
better, right?
It's as good as Octopus Deploy now, in my opinion. So they're all kind of similar now. Yep.
And you can mix and match them. Some people use Jenkins to both build and release. Some people might use TFS or Visual Studio to build, and then they'll use like Octopus to deploy. So, whatever works for you, just use whatever works. So, all right, I've closed those, and why don't you move on to the release?
Okay, perfect. So let's go ahead and talk about releases. So just like the build side of things, we have extensions that can help you with releases. So you can, again, all of our extensions are available on the Visual Studio Marketplace. And here's how we've defined our release here. So we have 3 environments: QA, staging, production, and we have different tasks within each of these. So we're grabbing the NuGet package from our, or the artifacts from our particle CI build, and we're feeding that into the release pipeline and deploying from those packages. So here what we're doing is we're comparing what the state of our database from the NuGet package, and we're comparing it against a target environment that we want to deploy to. So this is basically using the engine of our compare tool in the background to be able to compare 2 states of the same database going from the package to the target environment, identifying what's different, and also generate the actual Delta script or the update script that we need to execute against our target environment to synchronize it to match what's inside the NuGet package. So we've broken down that process into 2 steps here. So the first one, it just does the comparison and generates a report of what needs to be deployed. And then the second one actually goes ahead and does the execution of the update script that SQL Compare generates. So I'm going to go create a new release and promote build number 216, or the package from build number 216, to our higher environments. So let's go ahead and create that, which is going to then start the deployment process to our QA environment. A couple of things that I wanted to mention as far as releases or automating releases in general. It's very common for people, especially for DBAs, to be concerned around about automating their releases to any given environment on the database side of things. For a couple of main reasons. One is that obviously DBAs normally play sort of a gatekeeper role to production to make sure that they don't execute anything risky against their higher environments or specifically their production. So utilizing this unit test and the automated testing plays a very big role into making sure that if you're going down the automated release path, making sure that your releases are reliable and safe, and if there's any issues, whether it's basically bad practices with coding. I've come across a lot of DBAs who spend a lot of time reviewing scripts that are submitted by the developers to them, either through a ticketing system or email or whatever method that they're using, and they spend a lot of time checking for those specific things, like is there a select star from? Are they deleting a record without using a where clause and things like that? DBAs spend a lot of time on, and that's kind of what results into the deployments taking really long on the database side of things. So the idea of DevOps is that the more you automate, the better, and the more tests you automate, actually even better, because that makes your release process a lot safer and reliable, as well as allowing you to release faster and more frequently and be able to release smaller units of changes as a result. So, I'm going to go ahead and take a look at our release here. And okay, so as you can see, our deployment to the QA environment succeeded. So when we run the comparison, we're actually generating a report that, in this case, I'm saving it up to disk here, which basically is a report of what you're deploying and what objects are different and what the update script looks like. So we just deployed to our QA environment. So that was release number 4. And here is the report that we generate. So again, for those of you who are familiar with SQL Compare, this is basically the report that SQL Compare generates. We're comparing the NuGet package from build number 216 against our QA environment. And here is the difference in terms of the objects that are being deployed. So the get particle store procedure that we just added, and also the table that we just modified and added a new column to. If there's any risky changes or changes that could result into data loss, you would see a warning here. And then you can also fail your builds or deployment if there is any level of warning, or if there's a high level of warning, you can kind of customize the release process to fail those releases if there's any kind of warning as part of this process. And then finally, the script that compare generates here. So here's the alter table to add that column and to create that new store procedure against our QA environment. The nice thing about this is that by default, everything is encapsulated into a single transaction. So if for any reason the execution of your script fails, then it will roll back the transaction. So you don't have to worry about manually rolling things back to bring it back to its original state. And we were able to successfully execute that update script against our QA environment. So from here, I can go ahead and promote the same changes to our staging environment. The only thing that I'm doing differently here for our deployments to staging is that I'm utilizing a manual intervention step between the creation of that update script and the execution of that update script. So someone can review the script, make sure that everything looks good, and we are indeed deploying the right objects before it actually hits the target environment. So if I go back to my release definition real quick while that's running. And if you take a look at our staging environment here, you can see that instead of 2 steps, I actually have 3 steps. Let's wait for it to load, and here we go. So I have the perform create, which again does the comparison between the package and the target environment, generates that report that we just looked at, and then as part of the manual intervention, someone can review that report, make sure everything looks good, and then if they're happy with the changes that are going to the target environment, then they can approve it so that then it can go ahead and execute the script against the target environment. Okay, so in this case, once it's generated that report, it's going to stop the deployment. So if I take a look at my release here, we should be able to see that it's pending a manual intervention. Okay, so it's still creating the report. Okay, here we go. So it's now going to stop the deployment. It's going to ask for my manual intervention. TFS is sometimes slow in terms of refreshing its tab. So okay, so as you can see, a manual intervention is pending, and it's asking me to go and review that same report that we just looked at. So if I go back to our staging environment here, making sure that we are deploying the same objects. So because we're comparing the package to your environments, then if there's any environmental differences, then those will, compare will try to sync those as well. So if your environments are out of sync, then this report will be different going from one environment to another. But in this case, my and we can cut. Oh, so this is the QA one. Sorry about that. Oh, I think actually made a mistake here in my release definition. So instead of pointing my database to our staging, I'm pointing it to QA. So that was kind of my fault. So that's why the report doesn't contain anything, because we already deployed to that QA environment. Okay, great. So so that's basically what I had for the demo. So again, just to summarize what we looked at how you can utilize our SQL source control tool to easily source control your database changes, which is, the fundamental component for a successful DevOps process. And also we looked at how you can run tests against your database, whether it's unit tests or code analysis tests, and how you can automatically run those as part of your build process. So if a developer misses a thing, or they forget to fix a broken test or a bad practice, then those will be caught by the build process. And we also looked at how you can then take the package from your build and release it to your target environment through a consistent, reliable process. Okay, so at this point, I'd like to open up to questions. We still have 10 minutes, so hopefully we should be able to go through most of the questions that that our attendees have today.
Sure. So let me do a few based on the demo and what we're doing. So somebody's asking about subversion as opposed to TFS or stuff. So we support a bunch of control systems, right, Arneh?
That is correct. Yeah. So if I go back to our SQL source control and take a look at the setup tab, or actually just pick a database that is not linked to source control, and if I go to setup, as you can see here momentarily, we support these source control systems out of box. So you can link to any Git repository regardless of what Git server you're using. You can use Subversion and just provide the URL to your Subversion repository. You can use Team Foundation Server, as well as just committing to a local folder and then using whatever source control client tool that you're using to do your commits into your source control repository.
Okay. So somebody else asked about committing the T-SQL-T objects, and so those are, you have to install T-SQL-T in each database, right? Maybe you want to explain that process just this real quick, or
absolutely, yeah. So we typically recommend installing T-SQL-T mainly on your development box or whichever environment you'd be using to actually run those unit tests. So it definitely needs to go on the development box because that's where you're kind of adding your objects and writing your tests, and that's where you want to be able to run your tests. So when you get up and running with SQL Test, you can easily go ahead and select a given database from your SQL Server instance and then add that database to SQL Test. So what SQL Test will do then is that it will install the T-SQL-T framework against your database, which is basically utilizes the SQL CLR to add some objects to your database. So here you can see I have some tables that start with T-SQL-T schema. I have some stored procedures that start with SQL cop and T-SQL-T. So when you install SQL Test against any given database, it will go ahead and add all these objects to your database. So that way you can start creating tests against that database. You could also promote these unit test objects to your higher environments, such as your QA environment, if you want to run some more unit tests or SQL comp tests in your higher environments. But that's kind of optional. It really should only start with development, and then if you want to promote those up the chain, that's up to you. By default, our automation process excludes any unit test objects, any T-SQL-T objects, as well as any unit tests that are written against your database. So those objects don't make their way into production, but that's just an option that you can turn on and off. So by default, it's turned on as part of the automated delivery process, but you can also turn it off if you want those objects to actually get promoted to any of your given environments that you're deploying to.
Right, and the T-SQL-T, it's an open source framework. It's a script that you can just run yourself. SQL Test will just do it for you. So we just try to make it easy. So somebody asked if the changes aren't in one transaction, can they be separated out? So if like two developers are making independent changes to different tables and we're trying to deploy these out, can we separate those out to separate transactions?
So really the only way to separate those out is to, depending on, not through SQL compare options. So with SQL compare, your options are either we are deploying everything that are pending through a single transaction, or we're not using any transaction, or we're changing the isolation level of the transaction. So those are really the main options that are available to you. As far as changes coming from different developers and promoting those changes into different transactions, the only way that you can achieve that is by, let's say that one developer commits his changes and that triggers a build, and then another developer basically commits his changes and that triggers a secondary build. If you go ahead and deploy the first build, that will only sort of deploy the changes that were made by developer one. So that will go in its own transaction. And then if you go ahead and promote the other build, then that will basically take whatever is pending that was made by a second developer that we didn't have in the previous build, and it will promote those in a different release through a different transaction. So that's really the only way you can achieve that, is by sort of having separate builds for changes that have come from different developers, and then promoting those separately.
Right. The other thing I would say there is you could also use branching. So you could branch for each developer, merge one developer's changes into the master, do the build, deploy that, merge the second developer. Similar to what Arneh would say, but branching could help you do that too.
Exactly.
The one thing I'll say is that if you do branching, it becomes cumbersome and confusing. And if you're trying to limit the changes, I think you want to do what Arneh says and just make a build with specific changes, deploy those, then do another commit and build with the other changes and deploy those. Right, and that's kind of a DevOps
to keep
thing.
in mind. Yeah, the only thing to keep in mind is that the most recent build will also have, changes from the previous builds, because each build contains the full state of the database as opposed to just what was changed as part of the commits. So if there was any other changes that you haven't deployed yet, it will be included in that most recent build. That's the only thing to keep in mind with DLM automation.
Right, and that's a general software problem. I mean, every build,
exactly.
When you get a CU from Microsoft or SQL Server, that includes all the changes from previous CUs, because we can't deploy different sets of stuff to different people. It's just too cumbersome. So what else do we have? So somebody was asking about versions of SQL Server this stuff works on, and so I know we go back at least to 2008, right? Do we go back further?
We do, yeah. So I think it's safe to say that 2008 is. I think in some of the tools we even go back to 2005, but we definitely support 2008 all the way to 2017.
Okay. Let's see what else. Somebody says, can you use shared mode in Git? And I actually had somebody ask me this in England. I'm curious what you say, Arneh.
Yeah, really good question. So it is, so technically you can, but the main thing with Git is that it's, the purpose of Git is to give each developers their own sandbox, right? So they can commit locally, they can make their changes locally, they can make multiple commits, make mistakes, commit again without affecting anyone else. So if you're working with the shared database and you're kind of using Git, you can still do that, but it kind of defeats the purpose of using Git as a source control repository. The other thing to keep in mind is that every time in the shared model, every time you go to the commit tab of SQL source control, depending on how up-to-date your local repository of Git is that you're committing to, you might see changes from other developers that have already been committed by those developers into their local repositories. But because these changes don't exist in your local repository from that shared database, they'll just keep popping up here in the commit tab. So again, technically you can do it, but it's not recommended.
Yeah, so Arneh's been really nice. I think it's silly because what you're doing then is, somebody's asking if I have a shared database and everybody has Git. What you're doing is you have two places that you're making changes from. So it'd be the equivalent of if I had a Visual Studio C# project that I had a Git repository, but we lived on some share where somebody else could make changes in their project and it could appear in their repository too. You have two places to make changes and you're gonna have constant merge conflicts. I mean, ultimately, you don't want to share Git repositories in that way. As Arneh mentioned, they're separate.
Exactly.
Now, I understand if you have a shared database and you're saying it's really big and every developer needs a copy, fix that problem, right? That's a separate problem. I mean, if you're trying to develop like that, it's a little bit silly. Ultimately, there's data virtualization technology, Redgate SQL clone, and there's other products out there so that every developer can have a copy. But if you don't want to do that, then don't give developers full-size copies of production. They don't really need that to do development and testing, right? At some point, we do want that in our QA process or somewhere. But when I'm trying to determine how to, add a page or I'm trying to add a field to a table, I don't need thousands and thousands and thousands of rows of data or millions of rows, right? I just need a few rows of data to understand how that works. Okay, so I would fix that. How much time do we have? We're we're about out. There's a couple more questions. We'll stay on and keep answering, but let me, while I've got this, let me flip back to just close this out real quick, Arneh, because I think you've done
Sure.
a great job. We have an assessment to help you understand where you are at database DevOps. So that's at redgate.com/maturity-assessment. So you can do that. We'll copy these slides here in a day or so. And then if you have more questions, you need help, you need something else, database DevOps at redgate.com, or go to /solutions or the /hub to find information. Somebody did ask about us doing like a Zero to DevOps stairway or a set of articles, and I think that's a good idea. We've debated about that a few times, so maybe that's something we'll do. Arneh, I don't know if you have to go or not, but thank you very much. I think you've done a great job and hopefully helped everybody.
Absolutely, yeah, my pleasure.
Yeah, you're welcome to stay on, or if you have to drop off, do that. I've got a couple more questions. I'll stay on for a few more minutes and answer them, and then close out the webinar. But everybody, thanks for attending. If you want to go, please feel free, and you'll get this recording in slides in the email here in a day or so. And then otherwise, I'll keep answering questions. All right.
Excellent. Thanks, everyone, and hope you have a good rest of the day.
All right. Thanks, Arneh.
Thank you.
All right.
Bye.
All right. So let me go on. Somebody else, test scripts being automatically generated.